Imagine looking up at the night sky. You see stars, planets, and maybe even a faint galaxy. For centuries, we thought we understood the basic rules of the cosmos. We knew about gravity. It's the force that keeps our feet on the ground, holds the moon in orbit around Earth, and pulls galaxies together into massive clusters. But what if there was something else out there? Something invisible, yet more powerful than gravity across vast cosmic distances. This is the story of dark energy. In the late 1990s, two teams of astronomers were measuring how much the expansion of the universe was slowing down. They were using distant exploding stars called Type Ia supernovae, but when they put all the data together, the numbers didn't make any sense. The distant supernovae were even fainter than they should have been, meaning they were farther away than predicted. The only explanation was staggering. The expansion of the universe hadn't been slowing down at all. In fact, it had been speeding up for the last several billion years. This is where NASA's Nancy Grace Roman Space Telescope comes in. Named after the pioneering astronomer who was NASA's first chief of astronomy, Roman is designed specifically to hunt for clues about dark energy. Roman's camera will have a field of view 100 times larger than Hubble's. In one single pointing, it will capture a patch of sky larger than the full moon. Over its 5-year mission, Roman will create the largest and most detailed three-dimensional maps of the universe ever made, imaging billions of galaxies with unprecedented clarity. Roman will use a powerful technique called weak gravitational lensing. By measuring the shapes of billions of galaxies, scientists can map the invisible dark matter that lies between us and distant galaxies. The telescope will also look for a faint pattern left over from the very early universe, ancient sound waves that rippled through the primordial plasma, creating a standard ruler embedded in the fabric of the cosmos. By using multiple independent methods to measure the expansion history of the universe, scientists can be much more confident in their results about the nature of dark energy. At the heart of Roman's power lies the Wide Field Instrument, an assembly of 18 advanced detectors that work together to capture light from the cosmos with breathtaking speed and efficiency. Roman is built around a primary mirror that has a fascinating history. It was originally built for a different purpose by the National Reconnaissance Office and was eventually offered to NASA, a gift that saved the mission hundreds of millions of dollars. To hunt for dark energy, Roman must see the universe in infrared light. As the universe expands, light from distant galaxies gets stretched to longer wavelengths, shifting into the infrared part of the spectrum. Roman carries a second groundbreaking instrument, the coronagraph. This technology demonstration is designed to take actual pictures of planets orbiting other stars by blocking out the overwhelming glare of their parent stars. Roman will also hunt for thousands of exoplanets using gravitational microlensing, monitoring hundreds of millions of stars for the characteristic brightening events that reveal hidden worlds. This survey will provide a true census of planetary systems throughout our galaxy, helping us understand how common planets like those in our own solar system really are. Building Roman has been a marathon of solving fiendishly difficult engineering problems. Every component must work flawlessly in the harsh environment of space, with very little room for error. Roman will generate more data in its first few months than Hubble has in its entire lifetime. Scientists are developing new algorithms to automatically analyze billions of objects and spot the fleeting signatures of cosmic phenomena. The mission faces a race against time and budget constraints. The team must navigate the triple constraints of technical performance, budget, and schedule while delivering a revolutionary observatory. The story of Roman is the story of humanity itself, born from our innate curiosity about the cosmos. We are a species that looks up at the night sky and sees not just points of light, but questions. Roman stands on the precipice of discovery. It could confirm that dark energy is Einstein's cosmological constant, or find something far stranger, that dark energy changes over time, hinting at new forces of nature. Ultimately, the quest to understand dark energy is a quest to understand our own future. The fate of the universe is written in the nature of this mysterious force, and the Roman Space Telescope is our next great tool in reading that cosmic destiny.